We are from Group 7. The given title for our group is FPSO. So for the introduction, FPSO. So basically, FPSO is a floating processing, storage, and offloading ship. Is a floating super tanker and processing facilities combined, which is the primarily used in the industry of offshore of oil and gas. It has the process facilities on tip of the ship and also the storage tankers, which is a super tankers at the hull of the ship. So FPSO may be made of recent tankers changed to position the process facilities on the tip. One of the reasons why FPSO are widely used in recent decades is due to the recent opening of deep water well in horrendous torrency conditions that a rig production facility could not get their feet on. So, in industry and oil and gas, mostly floating production storage and offloading were converted to single hull super tankers. Besides that, at the LNG, which is liquefied natural gas logistic chain, where the natural gas is brought back to ambient temperature and pressure, especially modified ship being used, which is FSRU. So generally, there were four types of FPSO. The first one is FSO, which is floating storage and offloading. In this type of FPSO, which is FSO, it doesn't have any processing and production. It's just for the storage and transportation. So next for FPSO, which is floating production, storage, and offloading, which is the primarily used in offshore in industry. Next, for FDPSO, which is floating, drilling, production, storage, and offloading, which is in this type of FPSO, we got a drilling process. Last but not least, which is FSRU, floating storage regasification unit. So for the FSO, accumulation and storage of oil and gas at sea, secondary methods of oil and gas, transportation and storage, export to the shore by pipeline or shuttle tankers. For the FPSO, facilitates the processing and storage of oil and gas at sea, primary methods of oil and gas processing and storage, most advanced technology for deep sea oil extraction, floating vessel of FPSO designed to receive hydrocarbons produced by itself or from nearby platforms, easy to install and do not require a local pipeline infrastructure to export oil. For the FDPSO, the vessel is modified by the modular drill that is attached to the hull of the ship. Addition of drilling process can perform nearly all major functions associated with offshore oil and gas production. Last but not least, which is a FSRU, is a vital component required while transiting and transferring liquefied natural gas, which is LNG, through oceanic channels. Special type of ship used for LNG transfer. We're going next for the FPSO in Malaysia. Basically, there were several companies that apply FPSO concept in Malaysia. One of which the company is FSPO Ventures Sdn Bhd. Generally, these are FSPO in Malaysia. The first one is FPSO TK at South China Sea. So basically, these are the characteristic and specification for the ship. For the parameters for weight, the value is 81,000 tons. For the area, 350,000 meter cubic meter. For the volume hold capacity, 560 meter cube. For the process on the FPSO, which needs it products the desired product 2.2 million barrels in a year. For the manufacture year is May 2013. Location of the ship is South China Sea, and for the crew on board is 110 members. So we're going next for FSPO Layang in offshore field. Parameters weight 42,575 tons, area 250,000 meter cube. For the volume hold capacity 350,000 meter cube. Process on the FPSO is 2.5 million barrels. For the manufacture year is January 2015. Location of the ship at Miri, Sarawak. And for the cruise on board is 120 members. The third one, FPSO Helang in Miri, Sarawak. For the specification, weight 52,947 tons. For volume hold capacity, 80,885 meter cube. In process on the FPSO, 550,000 barrels. Location of the ship at Miri, Sarawak. And cruise on board 70 members. Last but not least, FPSO Bertam at Riau. For the parameters, weight 68,438 tons. And for the area, 12,045 meter cube. For the volume hold capacity, 133,560 meter cube. And location of the ship at Riau, Indonesia.
Okay, my name is Abu Bakar and I will explain about the FPSO design. So as we know, the FPSO design, it has a process facilities on top of the ship and also the storage tanker at the hull of the ship. So FPSO is usually secured by strong anchor lines that's attached to the seabed while mooring, and this allows the ship to be anchored and not being moved towards undesired location. So there are several designs in mooring, such as spread mooring and turret mooring. And turret mooring is also known as weather vane. These mooring systems are used to endure the FPSO position in the best position possible for onloading and offloading.
Okay, there are four factors to consider in FPSO design features. The first one is hull size. Hull size is the body of ship, which are side, bottom, and top side. Top side is the part of the ship above water level. The main requirements for hull size are configuration, payload, which is top side weight, storage, which is space requirements and deck area. For configuration in the hull, the first one is riser. We must consider type of riser that will be used for FPSO by taking account of riser selection factors. The factors are, first one is platform type, whether it is subsea or permanent or etc. So the second one for determine the type of riser is the depth of ocean floor. And then we must consider the weather condition, and then financial feasibility and the project timeline, which if it's in a long run, the project is in a long run, so FPSO is the best way of to use. So the diameter and operating pressure is also important, and reliability. And last one is the fluid corrosive properties. So the second one is the environment factors. The environment factor of well, surrounding and route to shore for transportation also play a big role to determine configuration for FPSOs. For example, if the environment is benign is relaxed, sprit mooring system and omnidirectional FPSO is the most suitable type of mooring to use. However, if it is harsh, a turret mode is suitable. A permanent or disconnectable turret also can be used in this condition. It is more economical to use disconnectable turret in harsh environment to reduce risk. Next is payload, which is its requirement are the weight of topside, which load all the process requirements, equipments and facilities including tanks, the storage requirements and density of hydrocarbon to be stored. This include the tanks which are in the hull and in the weight of storage. The turret and swivel weights, mooring and riser loads. So the payload is the ship load, which the load which the ship carry. So the next, storage is an essential factor as well. Storage requirements is calculated from one, production rate. Production rate of well and the FPSO itself must be taken into account to estimate the capacity of required storage to make optimum of time and cost. And the buffer storage required. Buffers are essential to store whether crude oil from well or processed crude oil to offload later. Offloading frequency and parcel, which is the size of offloading tankers. But if offloading is frequently done, the size of storage requirement can be reduced to lose some weight and optimize the cost. The spaces are the spaces that required in the hull for storage usage and hydrocarbon storage, including main storage, stock tanks, slope tanks, of spec tanks. And then ballast tank. Ballast tank is to provide the balance for vessel and the ship. Next, we also should consider tanks for fresh water, diesel and chemicals. For storage, there are produced water treatment in FPSO, diesel for fuel and chemicals for process. So we need this to store the product and raw materials in the ship. So machinery spaces, which is including propulsion, is needed too. And next is cofferdams, which is void, which is including around the turret pool. Cofferdam is to ensure the tanks are separated for safety reasons. Example, when leaking happens, we can easier make sure which tank that leaking. Usually tanker ship have cofferdams. So the last one for configuration is the deck area. Deck area is located at the top side of the ship. The area requirement is defined by required area for process facilities. It is modules to be sufficiently separated. It lay down areas and evacuation route. Third one, in the deck area, it have turret, which is optimal position to be determined. And next, in the deck area, have accommodation forward or aft. Aft is the tail of the ship. Forward is at the front. So accommodation is placed whether at the front of the ship or at the tail of the ship. And offloading station, which is usually aft, but 2 stations possible for an aft. So the second one is the factor to consider in FPSO design is disconnectable FPSO or disconnectable turret in FPSO. So it needs to meet all the relevant requirements for trading tankers. Full marine propulsion, which is including crew to operate. It needs to have double hull arrangement, which is a new requirement after disaster of oil spill, which is considering safety reasons. And disconnectable FPSO is used in usually converted tankers to FPSO. Next, for FPSO that is converted from tanker, it also needs double hull requirement and the design life versus hull condition. This is important due to limited residual fatigue life of the tanker. Life extension, which is including partial hull structure replacement, which is in an easier word, we need to repair the hull, is part of the conversion scope. The third one is conversion of the main engine, furnace system, and refurbished scope. So and the next one is project schedule, which is normally faster than a new build. The last one is project cost, which is normally less expensive than new. Next, these are the advantages and disadvantages process in FPSO. So as we can see here, the advantages is more than the disadvantages. Let's see the advantages. The first one is it can save time. FPSO can be connected to any pipeline due its connection flexibility, while permanent pipeline for transportation would take time to build and install. It is more preferable to use FPSO, which is free to go from one to well to another. It is especially suitable for small wells that would deplete in a matter of years. Second one is cost. It is cheaper in the long run. Building permanent pipeline would cost more on the long run, considering maintenance, well completion and platform decommissioning expenditures. When well has depleted and become unviable, the removal of equipment and capping of well procedure for abandonment process would spike the cost by hundreds of $millions. FPSO can minimize this as small permanent infrastructure is taken into account. And the third one is safety. FPSO is safer due to it can be disconnected from pipeline and oil wells if anything bad happened in well or the FPSO itself. FPSO also has flexible route rather than a fixed pipeline. For example, a severe weather condition can be predicted by FPSO, and a safer route would be chosen. But for fixed pipeline, they have to bear with it. So the fourth one is convenience. Oil producers can lease the vessel, so they have greater flexibility over their assets. They can react to market forces better. Some oil wells lack commercial viability due to weather hazards, distance to shore, of course, inefficiency of building and maintaining traditional infrastructure. This problem can be minimized by FPSO being flexible in deep water and various weather. FPSO also can store a significant amount of crude oil and gas so that there is no problem for HUD to reach fields to transport the oils. So the disadvantages are, the first one is the initial cost. Usually the capital cost to build FPSO is higher than pipeline for transportation. So the second one is conversion time. To convert a tanker from a normal tanker to FPSO, it needs 2 years time, but it is still viable. But even though it is still faster than building a pipeline, it is something to consider.
For last but not least, for the recommendation of an FPSO, normally an accident will have occurred in the oil and gas industry if the workers did not take safety precautions. In Petronas, the purpose of the accident analysis is not to accuse or blame the weakest number of the control hierarchy. It is instead intended to draw lessons that can be applied in order to improve the operation and safety guidelines of the operational process. A thorough review of the Petronas incident supports a collection of guidelines. In the event of an FPSO incident, they are divided into 4 groups, which is the first one is the technical infrastructure. Next, for business management. The third one, management and production. And last but not least is for the government and environment. For the technical infrastructure, the first one, the operator must strengthen the valve control system so that the operator must ensure before the production occurs for the process, make sure for the general shutdown and general open up the process is following by the procedure, so that the valve was not leaking or can't expert due to high pressure and extra. The second one, other alerts must be added to supplement the computer system, such as we install the alarm so the alarm can be triggered if an emergency case or an accident may occur. Last but not least, provide a reliable backup communication system to avoid degraded functioning and a loss of control. For the business and management, the roles, powers, and responsibilities of the different actors in the safety structure, the criteria used to evaluate decisions, the design and implementation of safety controls, the requirement for the systematic application of safety constraints. The third one for management and production, recommendation that need be to adapt is first one is to conduct risk analysis. The second one to investigate the reasons and conditions for the incidents. The third one to evaluate risk indicators, to systematically collect the data, to validate the training programs of operators, to compile the criteria to be adopted for safety control.